Hey, Tyler,
Yes, sir.
I'm gonna try to complete one of them walkthrough forums because they saying you gotta do like the operations, the different one. You know what I'm saying? We got a different kind of walkthrough form, so I'm just gonna let you know that I'm just gonna do that form so I can get one in.
Okay. You doing about doing it during class or during
Yeah, I guess I'm. Yeah,
right? Okay. Thanks for letting me know.
Good afternoon, gentlemen. Uh-oh. Can y'all hear me?
I can hear you, sir. Yes, sir.
You you got Lee Carter this period, right?
Yes.
Does he show up typically?
Late, but eventually he's.
Russ, can you hear me?
I heard Rush earlier. I don't know where.
All right, I'll come back. I gotta test Lee Carter.
Okay. All
Thanks,
right.
Tom.
So 5 more minutes for latecomers.
The, hey Tyler,
Yes, sir. Can you hear me?
does Hilario usually come in?
Castro, he comes late as well. Probably middle class.
Okay. All
Yeah.
right.
Yes, sir.
All right. I'll see you later.
They on point today. They're not playing. Hey, David. Welcome to class, dude. I saw what you did. That was pretty good work. He's giving me the thumbs up. Welcome to class. You might get your screen size so we can get into today's assignment. We got about 3 more minutes that I'm giving people to be late or absent. I'll mark them. And you got extra credit for coming actually 5 minutes before class started. 5 minutes after class, I should say. So 5 minutes before, 5 minutes afterwards, you get extra credit a little bit. Tamia Love, welcome to class. All right. Let's mark her present. So far, let's see. David and Tamia. All right. We're just getting there, giving people time to get in here. While you're waiting, make sure you size your screens. One screen should be Edsby. Another screen should pretty much be Google Docs. We're going to type up our problem. And if you want to get a jump start, just look at today's topic. It talks about power. I want to say. A couple more moments. People, time to get settled. It's right after lunch. Welcome to class, Mr. Carter. I think Mr. Borders is looking for you. He'll be in here whenever he comes. Let me reach out to Borders and let him know he's looking for you for star testing, I think.
Mr. Tyler,
Yes, Miss Love.
Amira said Amira said her internet not working and she's trying to get her computer together.
Amir's going to have to take the L and have attendance issue. She's still got to get the work done. Sorry, everybody. No excuses. If anything, tell her to reach out to Irvin, and he could probably help her out with an excusal. But otherwise, I have to mark her absent. All right. Okay, so policy of CPS is, I'll text Borders in a minute if he doesn't come back. So policy is you must keep your cameras on because we have to make sure it is the student that is present in class during that time for attendance purposes. We're going to go through our norms. It seems like everybody else might get here. Stop this a little bit late. Tamia, I was going to say, Tamia, can you mute yourself? You got a lot of background noise. Thank you. All right, so we're going to go through our norms real quick. There's Castro. Let me mark him present. And Castro, Borders will be back for you, and Carter in a moment. Please try to keep your camera on. Let me mark Castro present. There we go. Okay, should have saved. There it goes. I was like, I should have saved Castro. There it is. All right, we're going to go through our. Yes, Tamia.
What do this got to do with robotics and engineering?
I want you to look that up a little later because we got a lot to do. Power is a very, very powerful topic in terms of engineering because it deals with horsepower. And if you drive a car and you understand any of the things we've done, you will understand how they function. So these are trade skill calculations you're making. If you want to be paid anywhere from $60,000 to $80,000 a year starting out, to be able to do these type of calculations is how you get that money. Stevenson, welcome to class. All right, so I guess I can get started on the norms. I've been saying I'm gonna start on norms, but students keep coming in. And then, who is that? Stevenson, what you say? Okay, so we're gonna go through our norms. Rush, when you get a chance, I don't know if you have the opportunity. I know you're doing your walkthrough. Can you text Borders and let them know before? So the 5 basic norms. First on the list is David. Can you read number 1?
No one has the right to hurt another person.
Thank you. Next on the list would be Castro, number 2. Hilario, are you there? Okay, I'll come down the list. Lee Carter, can you read number 2?
Hello? No, he cool.
Education class of sacred.
Okay, Stevenson, number 3.
We will not behave in the way that we'll describe ourselves our school and our family.
Okay, some people are figuring out the raise hand feature. I'll read number 5. We take pride in Excel Academy of Southwest. Next, academic norms. Tamia, can you read number 1?
We respect the opinions of others.
Thank you. Next in my list would be, let's see, going back to the top at David, number 2.
We respect the culture of the classroom.
Thank you, sir. Castro, are you there? Can you read number 3?
We are attentive and participate.
Thank you. Let's see, Lee Carter, number 4.
We have high expectation of ourselves, our peers, and our teachers.
Awesome. And number 5, that would be, let's see here, Mr. Stevenson.
We are here to focus on preparing ourselves for post-minute adults.
Awesome. We just had Richardson. Welcome to class. You mark her present.
Hi, Mr.
How you doing? All right. All right, so we're done with our norms. Let's jump into today's problem, everybody. Change screens. Again, if you're on a computer, this is extremely easy to do. You'll be able to follow along with the calculations and the notes for this problem. So let's jump into it. Make sure you sign into your Gmail account, whichever one you use normally. And then what we're going to do is make sure you open your Google Apps. If you're signed in, this will appear, and go to Docs. Open a blank document. And then name your document immediately. So it's not supposed to be untitled document when you guys submit the work. It's supposed to be due now. This is what you always type, right? And honestly, it's today's date. It's just that simple. So it's today's the 18th. By the way, everybody else, tomorrow's report card pickup. I am giving out extra credit for students that have their parents come online. There's going to be a link where you can talk to all your teachers. And if they come online, participate, and ask questions about your scores, there's incentives to recover at least one an ungraded or lowly scored assignment. So just keep that in the back of your mind.
So do we got school tomorrow?
You guys don't. I do. So I'll be here waiting to talk to parents and helping them get their report cards to everybody. All right, and these are Q1 report cards, everybody. So moving forward, next you need the header, right? So that's your name, like I'm typing my name, and date again, so the 18th, and this is your signature line basically. Period is third, so third period, and you guys are intro to engineering students, okay? And this is with robotics, so let me not forget that. Now, power is a very, elegant concept because it shows how much horsepower. If you look at a car and see, how fast it's going to go, most people, they will look at the amount of horsepower or power from the physics standpoint that it generates to get across the road. So today we're going to look at this. I'm going to put it in the chat and we'll have a student read it for points. I think, who did not get a chance? I think it was Miss Richardson who came a little later. So I'm going to put this in the chat and you can read it for, if all of it shows. Yes, it does. Can you read it for 30 points? Do you see where it says?
Can I read
it? She just got here, Tamia. You got points with the norms.
I don't care.
Dang, that's so rude. All right, go ahead to me. I'll give her one other thing to read.
Hello, all future electrical engineers. Synchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well. Do I got to read the problem too?
You want the 30 points, right?
Okay, don't do that. To pass a slow-moving truck, a driver has to accelerate his fancy 1.30 times 10 to the third power kilogram car from 13.4 meters per second, 30.0 miles per hour to 17.9 meters per second, 40.0 miles per hour in 3 seconds. What is the minimum power required to do this?
Thank you, Tamia. Okay, so there's a few things we got in there. We got mass, we have an acceleration, no, we have a velocity. It looks like meters per second, right? And then we have another one. So one way to calculate this, because they're asking for the power, is to understand the power equation. So I'm gonna have, who is it, Richardson? I want you to read the second part for 20 points. Let me grab it. Ms. Richardson, do you see that in the chat there?
Yeah.
Okay,
Please remember to give maximum credit all calculation steps for the
Hey,
final
Mr. Tyler.
to the problem.
Yeah, they here, dude. I'm
needs
sorry.
to
Go
be
ahead, Richardson.
uploaded to ASB via.
Can y'all hear me?
Same format.
Hold on, y'all. Let Borders. What's up?
Who talking?
Richardson, let Mr. Borders speak for a second.
Oh,
Tyler,
okay.
can you hear me?
Yeah, we can hear you. Go ahead. Okay. Oh, he came back. Richardson, you get your points. Thank you, though. I know he's trying to get Lee Carter and Castro. Don't go nowhere. He's gonna be coming back for you. I guess he's fixing his microphone or fixing his speakers because he couldn't hear us. Stonewall. Okay.
Yeah, I think Stonewall coming to put the GGI link in the chat. Oh no, wait, I'm sorry.
GGI link.
I'm sorry. What?
All right,
I don't know what's
that's
going on.
my
I'm confused too.
Can you hear me, Tyler?
You turn the chat on? Yeah, I can hear you.
Please.
I just did.
Good. Mr. Lee Carter and Hilario Castro, I need you guys to follow that link and meet me over there now, please.
You guys see that link in the chat? Yeah, click on it and follow him over. Okay. So
real quick before
Hilario, I need you too.
go ahead, guys.
I was about to say before you continue, I was going to ask Mr. Stonewall, did he need anything? What did he need? But he left too, so that's cool. Proceed.
Okay, proceed. All right, so I'm gonna close the chat again. This is again important because you guys gotta get ready for your what is
Hold
it?
on.
Your star testing.
Hilario, you still here? I need you to.
Oh, he's put his finger in the camera. I guess he means wait 1 minute. I don't know.
Wait, I'm right here.
Right. I need you to follow the link that I just dropped in the chat. I need you to meet me in that classroom. In that classroom.
You got it?
Okay. All right. Thank you, Mr.
No problem. No problem. All right. So to do this problem, there's something called kinetic energy. You guys are going to have to remember. But let's put the title in here. Who knows the title today? I'm making it very obvious. Let's see who knows. I'm going to open the chat up. Who can tell me what today's title is? Nobody? It's in ESB.
Is it passing fancy power?
Yes, ma'am. You got it. 15 points. All right, let's type that in. She caught it. So all you have to do is just pay attention in ESB. It's passing fancy. And when she said power, that is our classroom term, right? Passing fancy. We're going to center this. And remember, our exit slip is always composed of two things. Let me expand this because I don't know if you can see that. So the first thing is you need your classroom term, right? And that is power. That's what she was just mentioning. It's in the brackets. And then the word of the day is pretty much what they said in GGI and Townhouse, retention. I also give out points for putting an objective in there. You can ask me what it is again later on. I'll put the screen up so you can see it and what these words are. But in order to get the points, you get to put the definitions of these two. So you got to put the definition of this one, retention. And you also need the definition of power. These give a verbal definition, and I kind of give it away in the clues of the problem. So what is the first thing we need? We need the first question, right? So that's 1S in our chat. So I'm going to copy that from the chat, or you can copy it from ESB. Let me put it right here, right after our exit slip part. Okay. Let's make this a little bigger for you guys. Okay, so you should have this much done. Don't forget, let's go back real quick to ESB. There is a homework problem, a 2A problem that you have to do. Now the goal is to get through all the steps so I can still give you guys clues on how to do the homework problem. So let's try to get as much done as possible right now. Okay, so then you should have both problems, your in-class problem you're gonna do together, and the homework problem 2A. Now, pay attention very carefully because the homework problem is very much similar, believe it or not, to your asynchronous problem, which we're doing in class together. All right, so what do we do at this point? Well, first and foremost, we want to work on defining what power is. If you remember, power was equal to, I'm sorry, not power, but work, because power has that in there. And I'm showing you on the screen what that looks like. Let me change screens for a second. So if we type in power formula for physics, right? You'll see this is what power is actually equal to. That's what it looks like. So let me copy this link and put it in the chat so you can see it. We're going to recreate that in our document. But that is the definition of power. There's another way to word it, and it's with kinetic energy. So it might not be as obvious, but it is. So let me put that in the chat for you guys. And that's how power looks. If you click on the link, you'll see that Google search, and it'll give you just what that should be. Okay, so let's recreate that. And you do that, side by side it. And we're going to say power. There's two definitions of power in this situation. Power, which is in watts, we'll talk about that in a moment, is equal to, what did it say again? I think it was delta, right? Or no, it's work. So work done. We talked about work all week, divided by next one, like delta T. All right, so let's go back. It's going to be delta time, or change in time. So I go to insert, because I'm going to put a delta in there. Special characters. And you want to select math instead of arrows and type in delta. It's a Greek letter. So DELTA. And click this. And time. So delta simply means change in time, right? Or change in. You can put delta Y, which means change in Y. You can put delta X, which is change in position. We're talking about this one here. So center your notes. And let's write this out in just basic plain English, right? Without all the math jargon. So that means power is always equal to the amount of work divided by change in time. It's delta. All right, cool. Next is, how do you measure this? Well, remember, at any form of power.
Mr. Tyler.
Yeah.
How you just get that triangle?
You go to insert. It's wide, actually. And so power is wattage, but you go to insert and special characters. Okay. Make sure you select the where it says arrows. You select math and type delta. Okay. Equals work, which is in joules, divided by the amount of seconds. That's time. Okay, so we got that part.
Slow down.
I can only go so fast. You got a lot of steps.
You move too fast for me.
No, I don't. I move like I'm trying to keep a job.
Okay. Yeah, but you move too fast.
So about okay, so are we ready, or are we still trying to put this together? Yes, no, maybe so. All right. So we have our initial notes, but we're forgetting one equation that's going to be key to solving everything. And that is pretty much our kinetic energy. So kinetic energy, if you don't remember, because we did this before, is equivalent to so it's delta, I'm sorry, 1/2 multiplied by the mass multiplied by the velocity squared. All right, so I'm put a 2 there and raise it to the power of 2. We talked about kinetic energy and we talked about work, everybody, so this is nothing new at this point. Okay, and come down. What is each of these measured in? And you'll see some similarities. So that means that kinetic energy is measured still in what? Joules. It's a form of energy, so like potential energy, work, or kinetic energy. So we're going to say 1 divided by 2 is 0.5. That's 50%. Multiplied by what is mass measured in? It's still measured in kilograms. And times your velocity, which is measured in meters per per second. And don't forget, there's a power of 2 that raises all this. So I'll highlight that and raise it. So I'm going to slow down for just a moment because it's 12:45 and we still have a lot more to go. A little bit more to go. Take a moment, take stock of these equations you're going to use. And let me, just to help you out, put it in the chat so you know how to set it up. So grab this and this and place this here for you guys. Those are the notes I've typed up so far in case you're like, to me, I'm moving too fast. I'll give you a minute to set that up, and then we're going to talk about our known and unknown values. So we get out of here at 1:20. It's 12:46. We have about maybe 30 more minutes left to get all this done. Okay, so now we're going to talk about delta kinetic energy, or change in kinetic energy, which is going to be essential when we're looking at what's happening with the car and the truck in this problem. So delta kinetic KE just simply means you'll have a velocity final and a velocity initial. So what does that mean, as students would say? Well, let's go through it. So we're going to take this, and what's going to happen is it's going to be minus. So let me come over here. And I'll put this in the chat before people are like, you moving too fast.
Mr. You trying to be funny? Don't do that, Mr. Tyler.
Yes.
So what I'm saying is, oh, and Amira said she not finna keep contacting Mr. Irvin over no goofy computer.
Okay. Tamia, you guys are being messy. Tell her to
No,
contact
I'm telling you what she said.
I don't want to know what she said because she's not here. So just
She
tell
on
her
the
to contact.
phone.
It doesn't matter. She's not here. You're being disruptive. Please stop that. It's just up to her to take advantage of her education. If she doesn't want to, that is on her. So I'm trying to finish the notes for you guys. So I'm going to drop this down. Okay. And I hope you saw that. And remember, delta means final minus initial, in case you guys forgot. So it's going to be minus, and then we're going to put this again. It's initial. And this is going to drop down. So let me do that. Okay, and that's how that should look. Ignore that. Okay, so you can see it. So this is essentially what you have. Now the equations is the part I didn't give you. So mathematically, we're going to use for power. I'll put this in the chat again. Power is equal to, so it's just simply P is equal to W divided by delta T. So I'm going to grab this delta. And it's T. That's the equation for power. The equation for kinetic energy, well, it's going to be similar. So for kinetic energy, it's K dot E, capitalized, equals 0.5 multiplied by your mass, multiplied by velocity, and squared. So you raise that to the power of 2. Okay. So far so good. Now we got to write a math equation for this section. Come down 1. And again, we know what these things are measured in. So let's put it into perspective. I'm not going to rewrite all the dimensions for you, but I will tell you this equation. So that's going to be what? It's going to be, like I said, delta, because we're doing a change in kinetic energy. Delta KE, right? Equal to what? Well, we could use 0.5. It's easier on us to use these constants like that, right? So 0.5 multiplied by M multiplied by, you could put V and then F, so you make it easier on you. We do the calculations. It's called denotation or subscripting. And turn it off. Minus, well, you guessed it, we're just going to change it from VF to VI for initial. So let me grab this over here. And this will be VI. So far, so good. Okay, so now I'm ready for known and unknowns. So what do we know? Versus what don't we know? Now let me go back and put the notes in again for you all, in case you missed something. And I'm gonna start plugging it in, and then we're gonna start calculating things. Because you need, essentially, to find a total power, you need the kinetic energy. Because basically what you can use for total work is basically the kinetic energy. So it'll be the new equation here, in case you don't know or see what's happening. It'll be power is equal to delta KE, which is what we're going to calculate. We got to calculate that first. That's one of our unknowns. And this is all going to be divided by some parentheses, our delta T, right? Now it'll work out, because this is going to, the delta KE is a form of joules, which is also a form of work, right? And all I'm saying is this is the same. Maybe I should have put it there, but I want to put it twice. It's going to be a big one. So just understand it's going to cancel out to make what you need for power. All right, let's keep going. We're almost halfway through this problem. So what do we know? Let's look at the problem. Well, the car weighs 1.30 as a mass, 10 to the third kilograms, right? That's a lot. So it's 1.30, and this is your mass, right? Or M, is equal to 1.3 times 10. We got to raise that to the third power. So it's not 103 when you see it in the chat. It's actually going to be raised to third power. And then turn it off. And let's do this. And it's kilograms. What else did they give us? Scroll up and take a look at our problem. They say it goes from 13.4 meters per second. That's a speed.
Mr. Tyler,
Yes, Ksenia.
can you can you put that in the chat?
Which part?
All that, because I went
Okay.
to the bathroom.
Oh, okay. So here we go. Let's see if it fits. So this is the part that I edited for you guys, and then I'm doing your known and unknowns now. Okay, so you should see all that. And make sure you edit it correctly, everybody. Next is, what did I say? It goes from, so that's VI. I'm gonna take this from here. That's your initial speed or velocity. So it goes from, didn't do it correctly. Let me go back. It didn't capture the I the way I wanted it to. There we go. And come here and say no, go over there. And it's equal to
David Murphy go to this school.
What did you say, Richardson?
My bad.
It's all right. 13.4 meters per second. Okay, that's the first speed they gave you. They gave you another one. And it says in a problem, it goes from, right, from 13.4 meters per second to 17.9 meters per second. Okay, so 17.9 meters per second is our final velocity. So I'm going to take VF and come down here, place this into the side. And make sure we note it correctly. There we go. And what did I say that was? That was going to be 17.9 meters. Okay. So far, so good. We know our mass. We can calculate the kinetic energy. Did it give us anything else? What is the minimum power? So no, now we can begin calculating two things. One, I told you already, you got to first calculate delta KE. So that's the first thing you want to calculate in your known and unknown values. Question mark, and that's going to be in joules. Once you do that, you calculate the power. So that is P is equal to, for power, some number in watts or wattage. As in, if you look at certain light bulbs, you have a 60-watt bulb, 20-watt bulb, it's watts, right? So that's power is generated for you to have light in your house. Okay, so we got this part. Let me grab this and put that in the chat next, in case you guys need it. Make sure you edit your stuff correctly. We got share outs in a moment. It's 12:58. We got about 22 more minutes of class. So I want to hurry up and get this done so we can do share outs. So what's your strategy? I kind of told you already in the unknowns. First, solve for, what did I say? Delta KE, right? Let's change the kinetic energy using the equations above from your notes in the center. Next, what do? Well, let's grab that equation. And how do we calculate it? By plugging the values in. So let's see what that looks like. This is the equation for kinetic energy. Now I'm going to plug the values in. So what do we got? For mass, we know that to be what? In our known values, we said that it is, where is it at? That is going to be 1.30, right, times 10 to the third kilogram. So let me grab it from here. Let me put this in parentheses because that's the mass. Okay, so far so good. What about the final velocity? Well, we know VF is this number here, 17.9 meters per second. So I'm going to grab this. I'm just literally taking what we've set up from the last step I put in the chat and putting it into our equation that we defined. So that's going to go here. I finished doing this. We got the same mass, so I'm just going to grab this part. The mass doesn't change from one situation to the next. It's still carrying all that mass with it, even as the speed changes. And lastly, VI is, we said 13.4 meters per second. Grab it and plug it in. So far, so good. Now, some things are going to cross out, and this equation is going to get a little smaller. Let's do that. What crosses out? Well, you got to understand, kilograms and meters per second will cross out to make joules. And also, these are squared. So let's fix this real quick, because this is meters per second squared in each term. So let's fix that. Where's the VI? These are supposed to be squared terms, by the way. So I'll fix that and send it to the chat for you guys. So there's a 2 here. This is how it's supposed to look. Like something's wrong with the cross cancellation feature. So 2, and I'll put that raised to a power of 2, so it looks right. And then the same thing, this has a 2. And then you're gonna raise it to the power of 2. So just make sure you fix that line of your code or your what you're working on. So each of these will have a 2 here for the speeds. So this is supposed to be a 2 here, and there's supposed to be a 2 there. And all these are raised. So let's do that. There we go. That's better. I can grab it and put it in the chat for you guys. Okay, let's just fix these. You want meters squared per second squared to make joules. That's the thing. Then I'm gonna grab it and put it in the chat so you guys can keep up. All right. So these are cross out. I do that before I put it in the chat. So remember, kilograms and meters squared per second squared, they will cancel to make joules. And then the end result here is joules. And then the same thing occurs here where the end result will be joules after you cancel things out. So we're going to cancel out this one, because this is going to make meters squared second squared for you guys. All right. And this is gone too. All right. So what does that look like? Turn this off to write joules. There we go. So a new equation, it cleans itself up in this next step. And that becomes this, but with the correction. So we know kilograms are gone. Meters per second are squared because they're squared, but they still say squared there in joules. And we got these gone too. And don't forget about these. Now we got this unique situation. So let's finish it up. We're going to consolidate everything so you can make a final calculation to get power. And that's like the last step, just calculating the power. So we know that we're going to have just one set of joules, and all of this is going to be calculated to make our total change in kinetic energy. So let's calculate it out and then get power and finish this problem off so we can try to do share outs. So what is all this jazz going to become right here? That's what you got to put in Math Papa. So let's do it slowly together because we still got to calculate power. And grab this so you guys can catch up while I calculate the power for you. So here you go. Make sure you cross out the right things, everybody. All right, how do we calculate power?
All right, hold on. Let me take a picture so I can know what to cross out.
Okay, leave right there. We got 16 more minutes of class, everybody. I don't know if we're going to have time for share outs and class points, but.
Mr. Tyler.
Yes.
So when we do like number 2 for our homework, do we do it the same way how we did the first one?
Well, yeah, you got to first find, because they give you kilograms, they give you the same way, just set it up correctly. They even give you time. So if you could calculate the work first, which is your kinetic energy, right? Like I showed you, this delta KE, this part, and figure that out with your known and unknowns, you'd be great. And the
Okay.
power is just the next step, like I'm about to show you in this step. Okay, so once we calculate delta KE, and here's how you do it. I'm gonna grab Math Pop and put it in the chat for you guys. We have about 15 more minutes of class left. And you open up Math Pop, or if you click on that link, and side by side type in what I type in. So the first part is 0.5. We'll put in parentheses everything. 0.5 times, what was it, 1.30. Hold shift and press 6 to raise something to a power. And I should have did that. So let me come out of that. Delete that part. Times 10, then hold shift. And it's to the third power. Come down, multiplied by, what is that, 17.9. And it's going to be hold shift, press 6, squared. Close parentheses. And I got to also come over here. Close parentheses. No, not for that one. This one. There we go. And what's next? This is going to be minus. It's going to be all this jazz again, 0.5 times 1.30 times 10. I'm going to raise that to the third power. Multiplied by, and what do we have in this situation? That's 13.4. It's 13.4. And that's going to be raised to a power of 2. Close parentheses. You hit enter. And oh my goodness, I think I broke it. So what happened? Oh, I think this is the problem here. Check that. And then raise that to a power. All right, what's your glitch? There we go. I had to figure out real quickly what I did wrong. And that's going to be 91,000. That's a lot of kinetic energy. So this is going to become, we say 91,552.5, and that's in joules. Okay, so let's finish the problem off. We got to find work. All we did in our knowns is found pretty much the kinetic energy, right? But remember I told you in our knowns we still got to find the wattage, our minimum power. So what do we use? Strategy. At the final step, I swear to you guys, before class is over with. So strategy. Use the kinetic energy found. Do you have a question, Tamia?
Is we doing share outs?
I don't know if we have time. We might, though.
Okay.
Might just do the share outs tomorrow. Found in the previous step, which is above, to calculate power or wattage. So I'm gonna put that in the chat, all of this, guys, because I know we're crunched. So how do we do that real quickly? Go back to your power equation. And if you don't remember, it's this one here where I say you're going to use kinetic energy instead of work, because work is a form of joules and so is kinetic energy. I'll come here and I'm going to say, hey, I want to use this equation. So I'm going to grab it, come down 1. And at this point, you should just be plugging in values because you have everything else. It gave us time, right? Or did that? Let me see here. So yeah, we didn't put the time in. It's 3 seconds. So that's our delta T, everybody. So let's grab that. Delta T. I was like, something's not right. And that's delta T. That was 3 seconds, if you don't remember. It's in the problem, though. So 3.00 seconds. Now everything makes sense. So I'm going to grab this. 3 seconds. And I got it from the problem, as you can see it there. And we'll plug it in. So we know this is 3 seconds. Use parentheses for that. And delta KE, we calculate it right above. So it's going to be this number here. Okay. Boom. And you put seconds over joules over seconds, you get wattage. So let's clean this equation up and get it ready for calculation. Seconds cancels, right? And also joules cancels because joules divided by seconds makes watts. So wattage pops out of that. Yes, I know, Google. So let's clean the equation up, and you guys got to calculate the final power on your own. So this is gone, and this is gone, and your final answer is just you doing that division of those two numbers. And make sure you write watts at the end of the calculation you find. So this is the final step for you guys. Okay, so that'll be all the steps. Let me grab, did I put that in the chat? I did. Yeah, I did. Okay, so let me grab the rest of the steps that I did for you guys. And don't forget what goes in your known values is time. I don't think we put that in there correctly. So time, again, these are your known and unknown values and how they should look. All right, so is anybody ready to share out before we get out of here? Because 11:11, I think I did that in great time. So you have everything you need. Like to me, was asking about the second problem. You guys are using the same situation, but you got to take your time and set it up where you know what your kinetic energy is. You set your time up, all that. Okay. So questions. It's 111. Do you need to scroll up? Do you guys got all this? Is anybody ready to share? Yes, no, maybe. Y'all quiet. So I think we could share out tomorrow. Do you know how to turn it in? It's got to be turned in by 8 though. You're sharing out now or tomorrow, so not tomorrow, Friday, so you can get points towards in class. But you should have something done though, so you guys should be able to share out right now. So let's go down the list and see who's here. Oh, some people left early, it looks like. Richardson, you have anything you can share?
Yeah, but I gotta change the numbers and the calculations and cross out some stuff.
Okay, just show me how much you got done so I can give you some of the in-class points. Screen sharing is on for you guys. I think you should be able to do it, and I'm gonna turn my presentation off. So who would like to get their in-class points now or on Friday? Rush raised his hand. Okay.
I was just testing it.
Yeah, it works. They're trying to keep up. Okay, there you go, Richardson. All right. Waiting for your screen to show your Google Doc. I see.
We doing share outs.
Yeah, we are. Some people want to get their points today.
Me too. So hold on. I'm next.
Okay. Oh, okay. I see you got almost everything, Miss Richardson. Just make sure you finish the homework problem, and don't forget your exit slip part. You can stop sharing. Tamia, did you want to jump in there so I can write down your points? Richardson, you're free to go.
Yeah.
Turn it in. Okay.
Okay, see you.
I'm gonna know how to start sharing.
Can you share there?
Okay.
There you go. You're doing good. Okay. Can you expand that a little bit so I can see everything? Well, you got almost all the notes. You've been working.
You see it, Miss Tyler?
Yes, I do. Okay, you got to send in your notes and stuff, but otherwise, it's looking pretty good over there. Stevenson left early. I guess he didn't.
All right.
All right, you're free to go. Turn it in tonight to me, 8 p.m. Before 8
Okay.
p.m. All right. Who's next? David, what about you? You got anything?
Yeah.
All right, share your screen, sir. Okay, David. Oh, you edited nice. You did well. Now you got to answer those two definitions, right? Well, you mentioned the word of the day. It's retention. But you got all the notes, it looks like. So you just got to finish up the rest of the notes I gave you. Yeah. Okay. Okay, so just try to turn in tonight, but don't forget to try the homework problem. All right.
All right.
You're free to go. Get ready for your next class.
All right.
Hey Tyler. Oh,
Yes,
never
sir.
mind. Never mind. You still got. I'm gonna wait. Oh, okay. That was the last student. Yeah.